My name is Degaldoruwa and I did the OAuth OpenID Connect implementation for this project. This gem purchasing application did not have Google login, so we implemented it. And the grant type I used was authorization code grant, and I used OAuth 2.0 with Google strategy to do this. First, I started setting up my Google Cloud Platform profile. So that I went to APIs and services and set up a client ID for this web application. And this is the authorized JavaScript origin. I use the localhost 3000 because this is run and tested on a local server. And these are the authorized redirect URIs. And after all that, Google provide us with the client ID and client secret. And after copying the client ID and the client secret and setting up the status to enable, I moved into the code and started setting up the passport, which is used to handle authentication in Node.js. And this is the code for the passport setup. And after that, I set up the routes for this platform, and these are the routes, and moved into the front end and implemented the logic and the buttons. And after that, let's move into the login page. This is the login page, and as you can see, there's a login with Google. And as you can see, the setting up the cloud platform worked perfectly here. As you can see, the sign in. They say the name of the application as well, Zillow Natural Options. So I'm going to type in my email. And after the two-step authentication, we are moved into the home page. As you can see, the login is successfully done. The email is shown here. And the next vulnerability that I found in this web application was the password storage, which was weak. And after encrypting the password, I have added a salt, which is a hashing method used with bcrypt, and the password are hashed. Those are my implemented parts. Thank you.
Hi, I'm Weerakoon. Today I will be discussing two key areas of security improvements we made in our application, which is authentication and authorization, file upload security. Let's start with authentication and authorization. In our initial implementation, we were using basic session-based authentication, which had several issues such as session hijacking and unauthorized access. To access this, we switched more secure token-based system using JSON web tokens or DWS. So here's how it is work. So when user login, they will receive a sign-in token that must be included in every request access to protect routes. This token is validated on the server, ensuring that only authenticated users can access the sensitive part of the application, such as adding or deleting gems. This is greatly reduce the risk of unauthorized access. So, as you can see in the authentication middle layer, we will extract the valid token. So, if there is no token, you will get this error saying the no authentication token found. So, unauthorized users can't access the admin page. In the front end, it will ask for the token. Otherwise, admin can't even send get request to the page. So the token is mandatory. So for adding gems as well, so it will require the token. Otherwise, user can't add the gems to the system. So receiving get the gem details as well, both will include the token, require the token. So updating and deleting the gem, both all will require the token. Otherwise, the user, the login user can't access those data. In this case, the admin can't add or delete or get the gems from the database without proper authentication. For file upload security, initially our file upload system allowed users to upload any file type. With those major security risks, the attackers could upload malicious files like scripts that could be executed in the server. To fix this, we restricted the types to only allow safe image formats like JPEGs and PNG. This prevents the attackers from here it is. This prevents the attackers from uploading potentially harmful files. Additionally, we set a file size limit to prevent large files from overloading our server, which could lead to denial of service attacks. So in this case, we limited it to 5 megabytes. So only below 5 megabyte files can be added to the server. We also implemented a unique file naming. This ensures that uploaded files don't overwrite existing files. So like this, which could cause loss of important data. Now every file renamed with a unique identifier being saved, ensuring integrity of file system. So these measures significantly strengthen the security of our upload functionality and reduce the risk of potentially server exploitation. Let me show our system now. So first you have to log in. So I will log in as admin. So now as you can see, we logged into admin page. Now for adding gems, first I will add an earning gem. So I will add some. So now if I choose a larger file size, as you can see, it's a 9 megabyte file. So I will try to edit and add gem. So I will get this error and error code while adding the gem. So as you can see here, I'm getting an error saying that file type is too large. So now if I choose another smaller file like this, so now we will add the gem. So as you can see, the gem is successfully added and no errors in the backend as well. So that's the file upload part, upload security part. So in summary, we address the key vulnerabilities in our both authentication and authorization, file upload security by implementing secure token-based system and role-based access control, and secure file upload practices. These changes have made our application much more resilient against common security threats. So thank you for watching. That's it for my.
Hi, I'm Janik Chaturanga Withanagamage, and today I will be discussing two crucial areas of security enhancement we did in our SSD assignment: input validation and injection attack fixes. And rate limiting is done by me. First of all, let's start with input validation and injection attack fixes. Initially, our application like proper validations for user inputs, making it vulnerable to injection attacks like SQL injections and XSS cross-site scripting. And all, then attackers could exploit these weaknesses by injecting malicious code into our input fields and then potentially gaining unauthorized access to the system. So to fix that, we implemented some input validation across all the forms in our system, both in the admin side and in the client side. For instance, we implemented input sanitization using libraries like DOM Purify to prevent XSS attacks. This ensures that any user input containing potentially harmful characters is automatically sanitized before being processed by the application. So in here there is a form. You can see we added some front-end validations in here. Also we added some validation in the admin side. Also we added some input validations in admin side. You can see them in here. These are the validations. Also we added it to the jewelry section. So that's all about our input validation and injection attack fixes. So after that I did the rate limiting fixes. So let's talk about rate limiting. Initially our API had no restriction on the number of requests a user could make, leaving us vulnerable to denial of service DOS attacks, where an attacker could overload the system with large number of requests. So to address this, we implemented rate limiting libraries such as express rate limit. I can show it here. We import it here and we use the rate limit here. That means we can we restrict users to making maximum of 100 requests per 15 minutes. If the limit is exceeded, the system temporarily blocks the user from making further requests. So also the rate limiting helps protect our system from the abuse and ensures that resources are fairly distributed among users, preventing attackers from overwhelming the server. So that's my part of this assignment. Thank you.